Hey, all you square root fanatics. Hope everybody's doing okay. We're going to talk today about simplifying radicals, or simplifying square roots specifically. Just a little background here that the square root sign is also called a radical sign, and the index is the root you're dealing with. And we've only been dealing with square roots, so the index is 2. But in Algebra 2 and beyond, you'll deal with cube roots, fourth roots, fifth roots, etc. Things like that, where the index is higher numbers than just 2. And in case you're want to use proper vocabulary at your next cocktail party, the inside of the radical is what's called a radicand. So we've talked about taking square roots and perfect squares and things, and there are definitely times when things are not perfect squares and we want to get a decimal value for how much that is. But there are other times in math where maybe getting that square root is not the final answer, and you don't want to use a decimal because a decimal is only a rounded answer, an approximation, even if it's a good one, because maybe you're going to then do something with it and plug that in somewhere and then do another calculation with it. And if you've rounded it way early in the problem, your final answer is not going to be as accurate if you've done 10 more steps with a rounded answer each time. So there's a way to reduce square roots, similar to when you learned how to reduce fractions. It has the same decimal value, but it's something you need to get comfortable with in math, and definitely in geometry next year you're going to do a lot with it, and in the future of math. So here's just to walk you through. If you were dealing with the square root of 324, the first thing you do is just try to take the square root of it. If you don't know it, try it on your calculator. And the square root of 324 is 18. 324 is a perfect square, so boom, square root is 18, we're done, we're happy. We love perfect squares. It's more about when it's not a perfect square. So for example, 12 is not a perfect square, and if you don't believe that, you're trying to say what times itself, what squared gives you 12. And of course that would be this irrational answer, 3.464, etc., etc. So rather than give that decimal, we're going to reduce this square root. And one of the methods we're going to talk about is using the perfect squares method. So 12 is not a perfect square, but are there any perfect squares that go into it, that are factors of it? And 4 is a perfect square, and 4 goes into 12. So we're going to break down 12 into two separate square roots, two smaller square roots. Square root of 12 can be broken into square root of 4 times square root of 3, because 4 times 3 gives you 12. And now 4 is a perfect square, so take the square root of it. Square root of 4 is 2. Notice there's no square root sign because we took the square root of 4 to get 2, so it's just regular 2. And 3 is not a perfect square, and it does not break down any further. There are no perfect squares that go into 3, so we're just going to leave it as root 3 or radical 3. So this answer would be called 2 root 3 or 2 radical 3 if you like. I like root because it's only one syllable, it's faster. But notice if you were to put 2 root 3, that means 2 times the square root of 3 in your calculator, you would get the same exact decimal because you're not changing the value of it. It means the same thing. You're just expressing this with a smaller inside number. So you're reducing the radical. That's what we call it, just like reducing a fraction. And so it takes a little getting used to, but once you do this, it really becomes second nature in math. So I'm going to show you 2 methods to do it, and there are others or a combination of these ideas. And so it's up to you. One, the fastest way is generally knowing your perfect squares. And the perfect squares, what we've been talking about, are things you can take the square root of. 1 is a perfect square, but that's not going to help you all that much. But 4 is a perfect square, 9, 16, 25, 36, 49, 64, 9 squared is 81, 10 squared is 100, etc. These are all the good numbers, the perfect squares that we're looking for when we want to do square roots. That's the way I like to think about it. So if I were trying to do the square root of 18, it's not a perfect square. So I'm going to ask myself, well, are there any perfect squares that go into it? Do any of these numbers go into it? And so it hopefully shouldn't take you too long if you know your times tables pretty well, that 9 is a perfect square and 9 goes into 18. So what I'm going to do, I'm going to break it down into two separate radicals, two separate square roots, and I'm going to put the perfect square as the first one. That's the one I'm going to do something with. Now, so it's root 9, and 9 times what gives you 18? 2. So I've just broken this down into root 9 times root 2. And now, if this is a perfect square, well, then take its square root. What's the square root of 9? 3. Root 2, 2 is not a perfect square. You know, its square root is a decimal, and there are no perfect squares that go into 2, so it can't break down any further. So we just leave it as root 2, and this is why I put the perfect square first and the non-perfect square second, because that's pretty much the way you're going to express it. So 3 root 2. That's the perfect square method. Here's the other method I'm going to show you today, which is called the prime factor method. Some people like this if they're not so good with their times tables and they can't think about perfect squares, and if they go in, here's one method you can do. You take 18 and you break it down to its prime factors. You know, give me any two things that multiply to give you 18, and maybe 3 jumps out at you first. 3 times 6, okay. And now 3 is prime, but 6 is not. 6 breaks down to 2 times 3. 2 is prime, 3 is prime, so these are the prime factors of 18. So here we go. Square root of 18 is the thing I'm trying to deal with, and if I really just rewrite that 18 as its prime factors, what is it really? There's a 2 times 3 times that other 3. Since this is square root, I'm looking for things that are squared. In other words, things that appear twice. So this 3 times 3, see how there are 2 3's that go in? Since there are 2 3's, I get to take out one of those things, because that's really 3 squared, and that's really 9. 3 squared is 9, and the square root of 9 is 3. So it just spits a 3 back out at you. So for every 2 3's, you get to take out one outside of the radical. This 2 is left over on the inside, and so you have root 2. Stays inside the house, and that's that. Same answer either way. Here's another example. We're just going to see this a few times so you can stop, rewind, watch it again, but at least you have a few different examples to look at. Root 600. If I were doing root 600, 600 is not a perfect square, but do any perfect squares go into it? And you might try and you might say, ooh, I know 4 goes into it. I know 25 goes into it. But what we're really always looking for is, what's the biggest perfect square? Sort of like reducing a fraction. Can you reduce it by the biggest number first? And if you think 600, well, you know that 100 goes into it. So that's the way I like to think about it. So why not just say, well, root 600 breaks down to root 100, and 100 times 6 gives you 600. And now take the square root of your perfect square. The square root of 100 is 10. Root 6. 6 is not a perfect square, and no perfect squares go into it. You might be thinking, no, 6 breaks down to 2 times 3, but neither one of those is a perfect square, so root 6 is completely reduced. So your final answer is 10 root 6. Easy. If you do the prime factor method, which is fine with me, it can be a little more time consuming, but sometimes people like that slow and steady. 600, maybe your first thought is, it's even. 2 goes into it. And 2 goes into there 300 times. Well, 300 breaks down more. 2 goes into that 150 times. 2 is prime, but 150 breaks down to 2 times 75. 75 breaks down to 5 times 15. 15 breaks down to 3 times 5. Okay, so if I were to take my time and say, here's root 600, here's what we're dealing with here. We've got 2 times 2 times 2 times, and I'm going to try to go in order just so I don't leave anything out. There was only 1 3, and there were 2 5s, 5 times 5. Remember, with square root, anything that appears twice, you get to take out one of those things. So there are 2 2s, and there are 2 5s there. And these are sort of the leftovers. Now what that means is on the outside you get to take out 1 2, and you get to take out 1 5. So on the outside you're going to have 2 times 5, and on the inside you have these sort of leftovers, 2 times 3, and now we multiply these back together. 2 times 5 on the outside makes 10, 2 times 3 on the inside makes 6. So 10 root 6. Same answer, but to me a little more time consuming. So I really recommend you try this and get good with your perfect squares. Root 48. Root 48. So here we go. This is sort of a classic one that people will not fully reduce. So I'm gonna do it first the way I think a lot of you might think about it. 48, not a perfect square. Do any perfect squares go into it? Yes. A lot of people will think 4 and 12, and 4 is a perfect square, which is good. So I'm going to break this down. Root 4 times root 12. The square root of 4 is 2, and then you have root 12. Not the final answer though, because what you've always got to ask yourself is, like a fraction to be completely reduced, for a square root to be completely reduced, you got to ask yourself, are there any more perfect squares that go into there? So 12, you should be thinking, ooh, 4 goes into that as well, so I can reduce it further. Now just watch out for this, because you've already taken out that 2, so that's just sitting there out in front, and it's just going to be multiplied by whatever you get from this. So root 12 breaks down to root 4 times root 3. The square root of 4 is 2, so that becomes 2 now on the outside, and root 3 is root 3. When you multiply those together, root 2 times 2 on the outside gives you 4 root 3. There's your final answer. Whenever you have to do more than one reducing step, it's okay, of course, but it really means there was a bigger perfect square you could have taken out at the beginning. Just like when you're reducing a fraction. Sometimes you have to do it more than one way. That means there was an easier way at the beginning if you had seen it. So it doesn't matter however you get there. But root 48, if you had thought a little bit more, you might say 16 is a perfect square, and that goes in 48. But that doesn't jump out to people maybe as quickly as 4 times 12. So 16 goes into 48, and 16 times 3 gives you 48. And the square root of 16 is 4. And root 3 is just root 3. So there's the answer for root 3, just a little faster. If you're thinking of the prime factors, you're still trying to make up your mind which way you like, totally fine. Maybe you start again with 4 and 12, and then you break them down. Well, 4 breaks down to 2 times 2. Those are both prime. 12 breaks down to 2 and 6. 6 breaks down to 2 and 3. Here's root 48. 2, 2, 2, 2. And 1 3 left over. Anything that appears twice, you get to take out one of those things. And I get to make 2 groups of 2. So I get to take out 1 2 on the outside and another 2 on the outside. And there's a 3 left over. 2 times 2 on the outside, 4 root 3. Either way. And lastly, root 72. Root 72 again is a common one that people don't do all the way correctly. So be thinking perfect squares that go into 72 because it's not a perfect square. What do a lot of people give me? Square root of 9 times 8. 9 is the perfect square. The square root of 9 is 3. And then we have root 8. But is 8 completely reduced? Any perfect squares go into 8? Yes, 4 goes in. So that means I got to do this again, this two-step reducing, which is okay. Just take your time and do it right. 4 is a perfect square. It goes into 8. 2 is, sort of the leftover here. And then what is the square root of 4? The square root of 4 is 2. And now multiply what's on the outside. 3 times 2 is 6, root 2. There's your answer. And of course, that means there was a faster way to do it. 72, not a perfect square. What's the biggest perfect square that goes in? And by the way, if you ever have trouble, sometimes kids think about it reverse. They think, does 2 go into 72? 2 is not a perfect square. But what does it go into? A 2 goes into 72 36 times, and 36 is a perfect square. So sometimes you can find the perfect squares that way by taking like a 2 or a 3, dividing it in, see what else comes out. And then 36 is a perfect square. What's the square root of 36? 6. Root 2, not a perfect square, doesn't reduce, done. 6 root 2 in one step. And just one more, seeing the prime factor method in case you kind of like that. 72. Again, 2 goes into it, it's even, so 2 is prime. 36. 36 breaks down to maybe 6 times 6 jumps out of you. And to be honest, if you see it appears twice there, you could even catch yourself and say, hey, if there's 2 6s, that means I'm going to take out 1 6, and I'll be left over with a 2 on the inside. So 6 root 2. You could get it right there if you see it, if you know what you're looking for. But if you don't, and you just go all the way with it, 6 breaks down to 2, 3. This 6 breaks down to 2, 3. And now those are all the prime factors. Here's what root 72 is. It's the square root of 2. And how many 2's do I have? Let's just be careful we don't leave any out. 1, 2, 3. So 2 times 2 times 2. 3 times 3. So 2 3's. Anything that appears twice, you get to take out one of those. Anything that appears twice, there's 2 3's. And there's this 1 2 left over. So I'm making groups of 2. On the outside, I take out a 2 and a 3. On the inside, there's this 1 leftover 2. And we have 6 root 2. Done. So whatever method works for you, just show your work on your homework. Show the steps you're doing so I know you did it and not some outside source, so I can give you full credit. All right? I want you to practice this either method you like, or use both if you like, So any questions you have, just please ask and hang in there. This is brand new stuff, so it might go a little slowly at first, but it should get better. Good luck, guys.